Hey everybody, it's Erik, co-founder, partner of Village Global, a network-driven venture firm. And this is Venture Stories, a podcast covering topics relating to tech and business with world-leading experts. Hey everybody, welcome to another episode of Village Global's Venture Stories. I'm here today joined by a returning guest and fan favorite, Delian Asparouhov of Founders Fund and Varda, and a new guest and portfolio CEO to both Delian and myself at Village Global, Chris Power of Hadrian. Chris, Delian, great to chat with you today.
Yeah, likewise. Thanks so much for having us.
And of course, this is an official based in Miami podcast, part of Miami Tech Week, and couldn't be more thrilled.
All three of us are in Miami right now, baby.
Exactly.
That's
it. So Chris, why don't we start with introductions? Why don't you give a background on what is Hadrian and how did the idea come to be born?
Yeah, so at Hadrian, the ultimate goal is to build the alien dreadnought, which is automated space and defense factories. Version 1 of that is a factory in LA, primarily serving launch vehicle companies and satellite companies. And basically the goal is to reduce the cost of advanced manufacturing in the States by an order of magnitude. And what we do, if we get that right, is speed up everyone in advanced manufacturing, 2 or 3 times faster. So everyone from SpaceX to Varda to Planet Labs can build everything that they're building 2 or 3 times faster. And, we are the Archimedes lever to build that makes everyone, go faster.
Yeah. And Delian, why don't you introduce, you came on the podcast, over a year ago and we did an episode on space. But since then, you've co-founded Varda. So why don't you give a description for what Varda is and how you came to start that?
Yeah, so Varda's incubated at Founders Fund. So I split my time between, both. Varda's basically making the world's first space factories, which in some ways, when you hear it, sounds like similar to Chris's pitch, but it's actually quite different. What we're doing is we're basically taking a set of materials that have a ton of benefit from being manufactured in a microgravity environment. So we take raw materials, bring them to orbit on a satellite, manufacture them up there, and then bring it back down and sell it to our customers. And so that's where, Hadrian's super helpful is there are many aspects of our, satellite and our factory that are up there that can have really long lead times and not be at the quality bar that we want. And basically Hadrian helps both with the quality as well as the lead times on being able to get those metal parts in-house.
And what was your thesis for Hadrian in terms of why were you so excited to back it and how did you think about it?
Yeah, I mean, It's been incredibly clear from working in this industry now even more closely via Varda, but also from a lot of my friends at SpaceX that this entire industry of aerospace and defense, especially when you need really high grade parts, is dependent on this just like large and very fragmented supply chain of basically like mom and pop machinist family shops. They're basically set up like back in like the Apollo era. They're effectively still run by the same guys that are now effectively like reaching retirement. And so it's like at Varda, if we needed like a really top tier sort of, mechanical part made, you end up basically like handing a 55-year-old guy like a USB stick. You don't hear from him for like, 6 to 8 weeks. And then you hope that you basically get a part that you actually want. And so when Chris came in and pitched it, it was in some ways like the easiest no-brainer of like, Varda was literally going to be a customer, had a lot of parallels. Actually, the way that we always described it internally was like the flex port for aerospace machine shops of just like building a nice software layer, but then also actually getting integrated into the actual like automations of the actual internal operations. That's what a lot of what Flexport does, right? Is they have a nice interface if you're like a, e-commerce company needs to ship things, but then they also have people on the docks and actually, operate a lot of software that automates the actual logistics as well. And so that was what was really exciting about Hadrian.
Chris, why don't you zoom out a bit and walk us through sort of how you navigated the idea maze for Hadrian? How do you think about sort of analyzing industry from first principles and attacking such a complex solution space?
Yeah, that's a good question. The answer is, a lot of boring and very hard things over a long period of time. But the first seed of that came from a software business that I was involved with in Australia, where we were selling software to blue collar companies. And I came to believe then that the right way to bring technologies to the industrial space, which is, more than half the GDP of the world, is to basically be the industrials business and design it in mind with software from the start. And that's how you really unlock everything. And in terms of root cause analysis of a massive industry like the space and defense supply chain, it's really just like a literal year-long process of thinking about what are the problems the customer have? What are those root causes at each layer of abstraction and tracking it down until you kind of reach the right layer of abstraction to solve it at. And frankly, that's a lot of like ego death analysis of multiple like logic trails throughout an entire year and talking to tons of people and like holding it all in your head. And it's hard to describe the methodology, but that's effectively what it is.
Delian, When you came on the podcast, why don't you give a brief overview of how the space has evolved since then?
Yeah, I mean, I still think there's sort of, three fundamental like groups within the various like space companies. There's basically what I call sort of like satellite operators. So these are people that, send up satellites, whether that's Planet Labs, Sky, what's it called? Starlink, Skybox back in the day, et cetera. And they take photos of the Earth or they communicate with the Earth and they just basically operate basically like almost like data centers up there. There's a second set that are the people that get them up there, what I call like the launch operators. That's everybody from Rocket Lab to SpaceX, et cetera. And then there's what I call like the supply chain, part of it, where there's people introducing, interesting new components that get integrated into satellites, people building satellites as a service. Across all three of these, over the past year have only, rapidly continued to mature. A ton more, satellite operators have now, SPAC'd and gone out. A lot of the even component supply chains, as an example, Momentus technically makes in satellite, propulsion has now gone out and SPAC. And then obviously on the launch side, we've seen a ton of exciting things. In particular, obviously Starship being the most exciting, since that has the potential to drastically reduce launch costs, which has a ton of implications across the entire supply chain. And so I kind of put Hadrian in sort of that, third bucket of, Hadrian's not sending, satellites up anytime soon, and it's not, building rockets, but it is a very core part of that, supply chain, but a slightly different angle on it of they're not producing satellite radios, but they're producing a wide array of different components that go into satellites.
Chris, I'm curious how you view it. We were talking about how you view more of an opportunity for atoms and bits in terms of returns in venture. And why don't you unpack that a little bit in terms of where you'd be investing if you were fully focused on that?
Yeah, I think there's a couple of ways to look at that. And one is from a purely investor standpoint, you want to be, the definition of an entrepreneur is taking a resource that is low valued in one domain and applying it to a domain where it's highly valued. And, I often say a C plus software engineer in an industrials business will, just crush everybody because the bar is so low. So one part of that is, looking for opportunities where the returns as an investor have been totally squeezed out of SaaS, and it's, it's a rigmarole and it's a kind of rinse repeat model. And secondly, mission wise, frankly, I don't like the fact that 90% of the smart people in Silicon Valley and in our networks are, optimizing ad click, making it go from 1.10% to 1.12%. Doesn't actually really help anyone. It's not very mission driven. It's certainly not going to help us breach through to the future. So yeah, that's how I think about it.
What's the why now for space in terms of how does sort of the macro economic situation or otherwise sort of influence the opportunity to build a space company at the moment?
Yeah, I mean, it's something that's been coming for a while. Obviously, you can point to Elon having a significant effect on this, but I think at this point, even if Elon hadn't existed, we sort of would have come to this point around this same period of time where access to space just required a certain level of innovation across a variety of steps of the value chain, and it's been steadily building on this exponential curve. If you look at just even the launch cost dropping over time, even pre-SpaceX, it was already headed on a very steep sort of dropping cost curve. And if you continue to extrapolate that, obviously Elon accelerated it, but we still would have been hitting these numbers in a relatively sort of near time frame. And so I think it's been a combination of a variety of the sort of different input levers into what it takes to operate a space business that are just starting to make these things more and more profitable, right? Planet Labs in 2009, 2010, hard to really turn a profit because so many of those input variables were so expensive. Now, ton of free cash flow that gets minted by that business because so much of their input, has gotten a lot cheaper. And then that makes investors more interested. So they invest more money into the space industry. So that makes things even cheaper. And it's sort of this recursive cycle that is just feeding on itself more and more and more.
Chris, what would you add?
I think, that is definitely true. I think one thing that people undersell is the SpaceX effect on talent. So one thing you need is this PayPal mafia approach of a bunch of smart people who then go create this Cambrian explosion of other companies. And, most of the people Elon recruited in the early days were 21-year-olds straight out of college. And now if you look at the design engineers or the founders of most of the other space companies, there's some pedigree from SpaceX. And now there's this known methodology of building things for space. And then obviously capital flows through the equation, but the people thing is, massively underestimated.
Yeah, the thing that's also recently changed is 2 years ago, there was no liquidity in the space market, right? The only acquisition that had ever happened was Skybox by Google back in 2009. Other than that, there'd never been liquidity. Now, all of a sudden, SpaceX is effectively a liquid stock. You have all these SPACs happening. And so that's causing a lot more people to be interested in the equities market. But then also on the debt side, people are actually starting to be able to understand and underwrite these businesses. And it just makes these capital intensive endeavors potentially half or even a third less capital intensive. Hadrian being a perfect example of this, right? Where like a lot of these sort of, equipment and the things that they need to sort of get the business going are things that are very well understood now by debt providers. And there's enough sort of, revenue flowing from all these various aerospace companies. They can underwrite the sort of future potential revenues of, Hadrian and make it so that like, something like Hadrian maybe would have had to raise, let's say, $100 million, like, 5 or 6 years ago in order to get to some level of like, quote unquote, I don't know, true revenue scale or like profitability, versus now you can probably get there with more like 20, 25 and like 75 of debt. And that just wouldn't have been possible 5 or 6 years ago. An aerospace company raising $75 million of debt, no fucking way. Like bankers would have been like, that's just, throwing money down the drain. We're super risk averse. We're conservative. Like we could never do something like that.
Yeah. And so what is sort of your request for startups in the space, or if there's a lot of smart people, listening in who are curious to go deeper and do something in this category, like where would you direct them, or like where do you want to see more innovation or experimentation?
Yeah, I mean, I think what I'd say is I'm not super excited by companies that are continuing to go after operating satellites or launching rockets. Those two areas are just extremely like, over inundated in terms of, opportunities, companies that are pursuing it. And like those markets, I think are like relatively stagnant. I think the areas that I get excited about are like, how can you basically, make the lives of those, pre-existing operators and pre-existing, launch providers a lot easier. So that could be anything from, there's some interesting companies popping up around just like software operating system type tools for, mission operations or being able to, do satellite operations, connecting those together, things obviously like Hadrian, enabling the like, supply chain, but there's different parts of the, supply chain as well, beyond just the actual like sort of metal manufacturing that could still require, a ton of improvement. So one of my favorite, ideas that I've, hoping to one day be able to fund is like, there still isn't like what I call like the Dell for satellites, where, right now, the reason that like, for example, Varda has to buy some off the shelf satellite components, and that entire system is going to cost us like 4 to 5 million. And the only reason it's costing us 45 million is because it roughly costs us like 2.5 million to launch the thing. And so it feels kind of crazy to like, you can't spend like 50 or 100K on the hardware and then 2 million to launch it. And then like, if the hardware fails, you're going to look like a fucking idiot. He's going to be like, dude, like, why did you spend 2 million on launching it and like didn't buy good enough hardware? Versus like, all of a sudden, if launch costs pretty soon are going to look like 100K, well, then you're going to look like a fucking idiot for spending $4 million on a satellite. Because it's going to be like, dude, like just send like 10, 100K satellites and it's fine if like 8 of them fail. Like, you'll still have 2 that are up there that are probably more powerful off the shelf components. And so this entire sort of satellite supply chain right now is really set up for this world where like the launch costs were extremely expensive. And now that they're rapidly cratering, I'd be really excited to fund something that basically, the reason I provide Dell as the example is just like mass manufacturing, consumer grade, just like, satellites that you can quote unquote truly buy off the shelf. Like people talk about off the shelf satellite manufacturers, but it's still like, year-long lead times. It's basically custom built. Like they're reusing some parts, versus I really want something where it's like, you can literally go to like a Best Buy and like, buy $100,000 satellite that is just like ready to fucking go.
Chris, how can we shorten feedback loops as it relates to hardware?
Yeah, that's a great question. So I think the first thing for people to understand is that like, imagine how crazy it would be if you could only iterate on a software product like once every 8 to 20 weeks. And yet that is the reality. If you're trying to do anything in like semiconductor or nuclear or flying cars or space or defense, in that design and production phase, you literally can only iterate 6 to 20 weeks at a time. And basically it's a lead bullets approach of like looking where all that lead time is, using software to clamp it down, reducing the error rate, because any error in manufacturing, you basically have to restart the process again. And then everything in manufacturing is basically series, and you want to parallelize it as much as possible. So, 3 simple ideas that are brutally complicated in the actual ground floor environment. But yeah, you're doing everything all at once.
Yeah, there's a couple of different examples that are starting to, come up in this space that I get excited by. For example, one of the like core manufacturing processes, especially in like plastics mostly, is like injection molding, where you basically create a mold, you inject plastic into it. Right now, those molds are very like manually done. There's some startups that are now working on basically automating that. So you make those cycle times on getting new molds and being able to iterate on plastic parts much more quickly. Metal 3D printing is obviously a huge area that's blown up that allows you to now, print these actual metal parts and like prototype, in-house. Another area in the world of electronics, once you get from like basically, like a circuit board to actually wanting to be able to create an actual, something that it looks like more like a chip that would actually go into your satellite, you need to create what's called like a PCB, a printed circuit board. Right now, those are like, sometimes, 4 to 12 week long lead times. There's a couple different groups that are now trying to do the equivalent of like kind of desktop 3D printers, but for printed circuit boards. So now all of a sudden your electrical engineers can also prototype super quickly. And so the problem sometimes with hardware is like there's a lot of different manufacturing processes and a lot of different disciplines. And some of those have gotten very fast cycles, right? If you need to like print a quick plastic part, yeah, that's actually been, done pretty damn well. And for the past 5 years, you can do it. You need to print a circuit board, good fucking luck. Like it's still 12 weeks. And so I think it's exciting to see startups starting to, chomp off a ton of these different challenges.
Yeah, I would also say there's a meta layer of software that is massively lacking. We're building a lot of that at Hadrian for our end, which is basically scheduling algorithms. So the process of going, hey, we've just designed a rocket ship with 1,000 parts on it. And, there's some assembly Gantt chart, which means that all the engine parts have to be delivered by October for it to be started to assemble in November, and then spreading that out to the supply chain so that it's all load balanced. Doesn't exist. Very hard problem. That none of the legacy ERPs that everyone uses like SAP are up to the challenge. And there's definitely like this load balancing software layer like you would find on AWS that is definitely needed as like a meta layer in the industry other than just the raw manufacturing.
Yeah, one day we'll get to the point where like, bits are controlling atoms as easily as they currently control bits, right? Like there's so much really exciting automation work that's been done, not only in like people developing software, but people making software that makes software, right? And so people are developing interesting ways to like make atoms. They're still not like the software to automate the making of the atoms quite yet that's really been like invested into. Like people don't really automate through metal 3D printers right now. It's still mostly the engineers decide on the CAD file, and they go put it in the metal 3D printer. But, as you start to develop these tools, that meta layer above it is where it starts to get really exciting.
And that's where the real key for Hadrian comes in, is that eventually we want it to be a series of factories across the country abstracted into an API so that a SpaceX engineer can do the whole procurement process as easy as someone as a software engineer just spools up another EC2 instance on AWS. Like literally supply chain, click the button, machine starts whirring in Texas or California or something. Like that's the level that you need to get this software to be able to make the whole machine fly.
Like at Varda, you're talking about, 18-person team. I would say almost like 6, full-time engineers are basically focused on effectively this like scheduling problem. We're just like, obviously there's some amount of design. What the hell do we build? But then once we design it, okay, how do we make sure that we're like, getting the right things at the right time, that they're at the performance level that you want, et cetera. It's not like manual labor per se. They're obviously like very highly skilled engineers, but it's the same thing as like there used to be, back-end engineers that would manually like, frag servers and sort of, spin up new ones. And then obviously AWS just started to create load balancing. And it turns out there's like a whole set of back-end engineering. There's actually like quite easily automated via software. There's a whole level of like mechanical engineering that is also actually quite easily automated via software. That, by the way, most mechanical engineers don't want to fucking do. Like it's, we like hire interns to hopefully do that stuff for us most of the time. But, no, like, 10 years out of, SpaceX engineer wants to actually spend their time doing this.
Yeah, that makes a lot of sense. Keith Roy is famous for his framework around, looking for, fragmented industries with low NPS and building, full stack solutions for that, open door and, or invested forward is another example. Why is it so important in low NPS industries to build full stack solutions?
So I think this goes back to, and I don't know Keith's perspective, but for me, it goes back to the root cause solution, like slapping a marketplace in a market where all the actors are bad or it's super low NPS doesn't actually solve any of the underlying problems that cause pain for customers. So you actually have to go down and like vertically integrate everything to provide that simplified full stack solution for the customer that's going to solve their problems. And a low NPS environment is a very easy way to identify that is the right strategy as opposed to doing a marketplace or a platform.
Yeah, the reason to do something full stack isn't just for sake of like increasing complexity in your business, right? Like Facebook clearly, became a very, very valuable company doing something quite simple that is not particularly full stack, just like, a little bit of software, social network effects, and turns out, that can make you very defensible. But when you don't have network effects, one of the best ways to sort of create something very defensible is, go into a market where there is all these low NPS players and just outcompete them both on customer experience, but then also in economics. And the sort of best way to do that is, tech-enabled players where you can offer both obviously a great experience, but then through technology, leverage your workforce to make it so that you can operate at a different margin structure, than everyone else. And so you don't want to do full stack just for sake of doing it. But in these fragmented markets, there's a reason why it's to provide better NPS and provide better economics.
Yeah, and to give everyone listening and you, Erik, the perspective of just how bad it is in, space and defense land. Unnamed big rocket company makes every single one of their suppliers take photos of the parts they order on the machines, like a cell phone photo, because if they don't do that level of like skeptical analysis of, hey, Bob, are you actually making the part? They get lied to and it shows up 8 weeks later. And, slapping a marketplace on that sort of a industry saying, hey, you can find Bob's machine shop slightly more easier now just doesn't cut it. It's not going to, get us to the future. It's not going to actually move everyone, in order of magnitude faster.
Totally. I want to shift gears here a little bit. One thing, Chris, that you were mentioning, you were talking about how manufacturing output is a key determinant of a win or loss in armed conflict. Why don't you unpack that a bit?
Yeah. So if you look back historically, there are very few situations where one side has a big enough technology advantage that it actually causes a win-loss scenario. Most technology stacks are kind of like within 10 or 20% of each other. It's like one type of gun versus another, or one type of plane at the other. What it comes down to is, an attrition war, and like how fast can you replace the resources that you are spending, which is why in like World War II, you see like oil fields being so critical and raw materials so critical because, all the German tanks get wiped out and you need to replace them, right? So what it actually comes down to is like, how much stuff can you build? How quickly, and can you sustain that over a long period of time? And this might change in the future, but at least historically, that is like the actual root cause of a win or loss condition.
Yeah, nuclear weapons only come out around once every 100 years that are actually step change functions in technology. They do actually fundamentally change the landscape. That is probably coming relatively soon in the world of space, right? The thing that is, often discussed in, defense communities is this concept known as rods from God, i.e. like basically controlled asteroids as weapons. They're more powerful than nukes, but then most importantly, they can travel much faster than nukes because they're coming in from orbit. As you're talking about things that are traveling, Mach 20 plus versus, we've never built any missile that can go that speed. And so anti-missile attack or detection basically can't stop it. And so you're talking about being able to very precisely nuke a city without any sort of countermeasures. And so there is the, potential for let's say a next piece of technology that changes fundamentally the war landscape. But again, those don't come around very often. And so most of the time it just comes down to who can build the most tanks and who can, throw the most soldiers at the problem.
Chris, how should we think about this uniquely as it relates to China?
Yeah, so the problem with China is that although they don't have as good fighter jets as us, their manufacturing output is just so much higher than ours that it's ridiculous. So folks can Google this, but the Japanese F-16 fleet and the pilots are getting worn down because China just scrambles jets into their airspace, forces them to wake up. All the pilots wake up at 2 a.m. and then they land the F-16s every couple of days. And those things can only land a certain number of time. And unfortunately, China can do that with almost no cost to them because they can just produce more planes at a whim, whereas the Japanese supply chain is actually the American supply chain, and we literally cannot produce that amount of planes just to handle that level of attrition. So the scary thing that people don't realize is that you want to have manufacturing overmatch, in the conflict, and right now we absolutely don't.
To give you a sense about like how much software can help here, Chris can speak to this example even better than I can. But there's, I think, like an old is it maybe the F-16 program or like bomber jet that like they literally like basically lost the original supplier for a certain set of parts, basically went under. And the US government has put out an RFP for somebody to basically come in, disassemble this particular like engine, find the parts, reverse engineer them, and then figure out how to manufacture them because nobody knows how to fucking make them anymore.
It's even worse than that. Like if you look at the defense readiness stats around like how many jets are ready to scramble at any given point in time versus the ones that are sitting on the floor and they can't be flown, it's like 50 or 60%. And if you track it back, it's because, Lockheed Martin sole sourced a part to someone 20 years ago and it's a 15-person machine shop in Iowa or wherever, run by a smart, entrepreneur, but they can't produce them in enough volume to keep the fleet alive. And it's just insane that that's the point that we've gotten the supply chain to.
To sort of hammer the point home, you've sort of made the point that we should, think about a bubble in the military, similar, with as much sort of vulnerability as we thought about the finance bubble. Why don't you unpack that analogy a bit? Yeah,
so I think that bubbles are created when previously competitive entities are no longer tested by the force of reality. And the US military does an incredible job of like wargaming and, making sure that we're as lethal as possible at any given point in time. But the reality is over the last 30 to 40 years, there hasn't really been a great power competitor that has really tested the reality of like whether in the current dynamic, our military force is as strong we think it is. And, don't get me wrong, I'll bet on America every single time. That's why I moved countries to like get this job done. However, I think there is the potential that you can look at US military lethality and readiness as a bubble in the sense that it's been going and going for 30 years without any real tests. And that there is huge similarities between that sort of a bubble monopoly untested dynamic and a financial system which suddenly pops one day. The problem is you only get to find out when there's a conflict, and by that time to retool everything, it's too late. And there are many, many people in the community that are aware of this. Tony Thomas, who's a partner from Lux, is well aware of these sorts of problems and working actively on it. And then you've got people like Christian Bros from Anduril who used to work for Senator McCain, who's putting out great material on this and really raising awareness. But that is the danger, that we think we're lethal and we are really not as lethal as we think we are.
So, Chris, we've been talking about conflict a lot, but of course, sometimes conflict is a way to, talking about conflict is a way to talk about how to have peace. So why don't you talk about your perspective on that?
Yeah, so, we've been talking about like military conflict and conflict in space a lot, but what actually everyone wants is a stable operating environment where entrepreneurs and nonprofits and everyone can act in space, and we're not wasting resources doing dumb things like trying to shoot each other's satellites out of the sky. And I think the best types of peace, there's two ways you create peace, right? One is like authoritarian peace, which no one wants because it gets nasty very quickly. The best type of peace is 2 to 3 major rational actors keeping each other in check. And the danger we face if we have a weak supply chain and a weak manufacturing output and China outstrips us is that will cause conflict, because we will either be trying to catch up to them and there'll be some nastiness around the edges, or we'll get into a scenario where it's like sizing someone up at a bar fight. If you think they're an even match, you're more likely to go over and shake the guy's hand and try and make nice and not make a big deal out of it. It's when there is a mismatch that people choose to opt into conflict. So having all this output and making sure our defense supply chain is strong and the space supply chain is strong is not about, being this like overt military power. It's just making sure that as China grows and becomes a global superpower and containment has failed, everyone knows this, it's that we continue to keep pace so that the leading system of engagement in space is democratic, rational, fair, is not authoritarian. It's not like algorithm governed, social credit scores. And that requires us to have roughly the same size big stick as the other guy. And there is a danger if we don't fix these problems that we don't. And that increases the chance of causing conflict.
If you look at over the past decade, plenty of people will argue that the number one technology that has saved the most lives is nuclear weapons. If you look at the by decade, deaths per capita, due to warfare massively dropped off after the invention of the nuclear atomic bomb. Now, that's held us in, a stable pattern for almost 60 years, but you're starting to see a disruption of that pattern from, the rise of China as an authoritarian power that is, equal, if not, has aspects of, advantages. You can see this even in their, latest, summit, with the Biden administration in Alaska, where, China for the first time stated very clearly, you no longer speak to us from a position of power. They, no longer see us as, the American superpower. They're convinced that, America is headed into a decades-long decline, and that this is sort of their opportunity to effectively, become the world's, single and leading superpower, as Europe has no, option. Russia is far too far behind. India, as a, large democracy, still has never shown a capability of significantly accelerating their GDP. And so it does feel like it's sort of, on, the American economy to, catch up and be able to, stay as that sort of, balancing superpower. And obviously sort of defense and aerospace being an incredibly critical component to that. And so I think, both Chris and I would say part of the reason we're excited to work in aerospace and defense, and the almost, if not the primary motivation, one of the top motivations for building our companies is because we believe in America being a really great country and being that sort of balance to an authoritarian power like China.
That is a good place to wrap. My guests today have been Delian and Chris. For people who want to go deeper, Chris, where can people learn more about Hadrian? And then Delian, where can people learn more about Varda?
They can go to hadrian.co and hopefully apply for some jobs, because we need all hands deck.
And Varda.com for Varda. Got a lot of job postings there as well.
Awesome. Thanks, Delian. Thanks, Chris. It's been a great episode.
Thanks, Erik.
If you're an early stage entrepreneur, we'd love to hear from you. Check us out at villageglobal.vc.